Hi students, good evening. Welcome to this video session. My name is Samuel Dominic Chukwu Emeka, aka Sam Down for Peace. In this video session, we shall discuss your 11.3 homework assignment. Section 11.3 homework deals with contingency tables. Please, it is important that you have read your textbook as well as the notes and videos, including the prerequisite notes and videos prior to viewing this video. We are going to use my calculator in this section. Question 1. The accompanied table summarizes successes and failures when subjects used different methods when trying to stop smoking. The determination of smoking or not smoking was made 5 months after the treatment was begun. If we test the claim that success is independent of the method used, the technology provides a p-value of 0.002. That's a rounded value of the p-value. What does the p-value tell us about that claim? So the p-value is small, is very small. It's small, and because it's small, you reject the null hypothesis. You reject the null hypothesis of independence between the treatment and whether the subject stops smoking. This suggests that the choice of treatment, when you reject the null means that there's no, like, it's independent, there's no difference. But with the alternative, it means that there is not independent, so there is some dependency, and that means it appears to make a difference. Question 2. Winning team data were collected for teams in different sports with the results given in the table below. These are the results here. Use the TI-83-84 plus results at a 0.05 significance level to test the claim that visitor wins, home/visitor wins, are independent of the sport. As you can see here, the p-value is 0.12361638855. At 5% or 0.05 level of significance, the p-value is greater than the level of significance. So because it's greater, do not reject the null hypothesis. Fail to reject the null hypothesis that home/visitor wins are independent of the sport. It appears that the home field advantage, if you look at the null hypothesis, is that it is independent. Okay, the home/visitor wins are independent of the sport. That is the null hypothesis. The alternative hypothesis is that the home/visitor wins are not independent of the sport. So because you did not reject the null, you did not reject the null, so we have to go with the null. Okay, and the null means that it is independent of the sport. So it appears that the home field advantage does not depend on the sport. Question 3. The table below summarizes results for randomly selected drivers stopped by police in a recent year. Using technology, the data in the table results in the statistics that follow. So these are the results of the data. I mean, the results of the technology, of the use of technology. You had data, you used technology to run some tests, and these are the results. Use a 5% significance level to test the claim that being stopped is independent of race. Based on available evidence, can we conclude that racial profiling is being used? So we look at the p-value. The p-value is 0.906. That's really high, a high p-value. And the level of significance is 5%. So the p-value is greater than 5%. When the p-value is greater than the level of significance, you do not reject the null. Okay, you fail to reject the null. In this case, the null hypothesis is that being stopped by pleas is independent of race. The alternative hypothesis is that being stopped by pleas is not independent of race. Okay, so there's a dependency. So because we fail to reject the null hypothesis in this case, because the p-value is greater than the level of significance, that means that we do not we will not say that there is racial profiling, because here we do not reject the null hypothesis. The null hypothesis is that being stopped is independent of race. So that is as regards this question. So if you read the options here, can we conclude that racial profiling is being used? We will say no, because the p-value is greater than the significance level. Okay, does this make sense? Please, if you don't understand it, feel free to ask questions, please. Question 4. The table below includes results from Polygraph, which is lie detector, experiments conducted by researchers. In each case, it was known if the subjected lied. In each case, it was known if the subjected lied or did not lie. So the table indicates when the polygraph test was correct. I think there's some grammatical errors here. Now, use a 5% significance level to test the claim that whether a subject lies is independent of the polygraph test indication. Do the results suggest that polygraphs are effective in distinguishing between truth and lies? Determine the null and alternative hypothesis. So the null hypothesis will always be the independent, that this variable is independent of this other variable. And the alternative will be that this variable is not independent of this other variable. So we're going to use the correct option is C. Determine the test statistic. So I'm going to pull up my calculator. You can just go to google.com. That's another way you can do this. And you can do hypothesis testing. You can do hypothesis testing HubSpot. And that's the first it comes up, hypothesis testing HubSpot. Or you can get this, you can also get it from my portfolio. You know how to get to my portfolio. You can go to my website, samuelchukwuemeka.com, and go to portfolio and look for web apps, and you will see hypothesis testing calculator. You can also get it from here. All right, we're gonna let's put this to be on the same, see whether we can get this the same page. Yeah, this calculator will not work by messing with these 2 pages, so that's fine. I'm just gonna make this big. I'm gonna make it big page. That's fine. It's better to work just by itself. So let's click on the icon to view the table, and this is what we're gonna put in. So with the calculator you're gonna use here, if you scroll down, you go to contingency table, test of independence. That is this topic is test of independence. Contingency table is two-way frequency table. It's two-way table. So you just click here, sample data right-tailed. And here it asks you how many rows, which means actual numeric rows. Like we care about the numeric, okay, about the numbers. How many rows does your table have? So in this case, don't count this non-numeric, just count the numeric. We have 2 rows and 2 columns. So you put 2 rows, 2 columns. Then we want to fill this 20, 13, 45, 7. 20. Actually, let's do it by row. Okay, 20, 45, 13, 7. 20, 45, 13, 7. Significance level is 5%, or you can use 0.05 and select decimal, and then press calculate. If you were taking this in a traditional setting, your professor would want you to show your work. Your professor probably would want you to show all your work, and this is all your work here. You're gonna add the rows, you're gonna add the columns, and you're gonna calculate the expected frequencies for each data value. So you have to show all this work. But in this video we are just using technology. So the chi-square test statistic to 3 decimal places is 7.545. 7.545. P-value to 4 decimal places is 0.0060. Do the results suggest that polygraphs are effective in distinguishing between truth and lies? So here we reject the null hypothesis. And when we reject the null hypothesis, there is sufficient evidence to warrant rejection of the claim that the 2 variables are independent. So there is sufficient evidence to warrant rejection of the claim that whether a subject lies is independent of the polygraph test indication. So that's the question 5. Please, when you finish this, you can just refresh this page. Now, if you want to, something I really found out today, when you refresh the page, if you click on this, it still leaves this data here, and then you have to click reset. You have to click reset to remove the whole thing. Okay, you can put this, right now you can make this a secured site. You can actually make this a secured site. Something I found out today. If you make it a secure site, once you refresh, it will erase everything. And how can you make it a secure site? You type the HTTPS, hypertext transfer protocol, secured protocol, and then you type https:// twice, and then hypothesis testing.appspot.com. That way is now, whenever you see this green is, is secure. If you click on this now, it says secure connection. That's the thing. So if you want to make it secure connection, that's fine. So question 5, results from a civil servant exam are shown in the table to the right. Is there sufficient evidence to support the claim that the results from the test are discriminatory? Use a 5% significance level. Let's state the null and alternative hypothesis. Excuse me. So the null hypothesis will be that the white and minority candidates have the same chance of passing the test, and there's independence. They have the same chance. It's independence. And the alternative will be that the white and minority candidates do not have the same chance of passing the test. Determine the test statistic. So this will be 2016 828. So we come here. This is 2016 828. And the significance level is 5%. Okay. Calculate. The test statistic to 3 decimal places. The chi-square test statistic. Chi-square, observed chi-square value to 3 decimal places is 8.416. The p-value to 4 decimal places is 0.0037. Let's look at the decision and conclusion here. Reject the null hypothesis. And these are the reasons. These are critical value method, testing it with the critical value method, and testing it with the p-value approach. Reject the null hypothesis. Of course, these two methods gives you the same decision and of course the same conclusion. So the decision is reject the null hypothesis because there is sufficient evidence to warrant rejection of the claim that the two variables are independent. So we look for that option here. There is sufficient evidence to reject the claim that a white candidate is more likely to pass the test. No, this is not that claim. We reject the null, and the null is that the reject the null hypothesis, which means that the white and minority candidates have the same chance of passing the test. So when you want to make your conclusion, you really have to be careful about the wording. Some textbooks, the way they word it is a little bit confusing. So you really have to kind of look at it to before you select your answer. So when we reject the null hypothesis, which means that they have the same chance of passing the test, because that's the null, that they have the same chance of passing the test. So when we reject it, that means we have sufficient evidence to prove that is biased, that they do not have the same chance of passing the test. So there is sufficient evidence to support the claim that the results are discriminatory. That's what it means. Okay. That's actually what it means. Question 6. Many people believe that criminals who plead guilty tend to get lighter sentences than those who are convicted in trials. The accompanying table summarizes randomly selected sample data for defendants in burglary cases. All of the subjects had prior prison sentences. Use a 5% significance level to test the claim that the sentence, sent to prison or not sent to prison, is independent of the plea. If you were an attorney defending a guilty defendant, would these results suggest that you should encourage a guilty plea? So the null hypothesis here would be that it says here, use 5% significance level to test the claim that the sentence is independent of the plea. So the null is that the sentence is independent of the plea. The alternative is that the sentence is not independent of the plea. Determine the test statistic. The table is 2 rows, 2 columns, 369, 55, 580, 43. 369, 55, 580, 43. So let's just refresh this and get this here. Oh wow, looks like this didn't work with a looks like this didn't work. I thought this would work with a secured I thought this would work with a secured protocol once I click refresh. Ooh. Okay, we'll just reset this, that's fine. But some people, if you want to browse in a secured format, anytime you see this green padlock, and then when you click on this, it tells you that it's a secured connection. So this is 2 rows, 2 columns, 369, 55, 580, 43. 369, 55, 580, 43. And that is 0.05 in decimal, or you can put 5 in percent. Calculate. So the chi-square statistic to 3 decimal places is 10.955. The p-value to 4 decimal places is 0.0009. Reject the null. Reject the null hypothesis. There is sufficient evidence to warrant rejection of the claim that the 2 variables are independent. So the 2 variables, sentence is independent of the plea. So reject this null. There is sufficient evidence to warrant rejection of the null. Or you can say there is sufficient evidence to support this claim that the 2 variables are not independent. So of course, when you reject the null, that means you're supporting the claim of the alternative. So let's read the options here. There is sufficient evidence to warrant rejection of the claim that the sentence is independent of the plea. The results do not encourage pleas for guilty defendants. So when you look at this here, look at A and C. A and C, of course, the decision, the conclusion is right for the A and C, but now the interpretation, whether the results encourage pleas for does the result encourage pleas for guilty defendants or for not guilty defendants? So we can say here, because there is sufficient evidence to reject this null, that means that whether they plead guilty, the pleading guilty tends to actually get lighter sentences. Because if we did not reject the null, that means that pleading guilty is independent of getting lighter sentences. That's what it means. If we did not reject the null hypothesis, the null hypothesis is telling us that the sentence is independent of the plea. So it doesn't matter whether they plead innocent or guilty, that the sentence is independent. They can get lighter or heavier sentences. It doesn't matter whether they plead guilty or not. That is the null. Now the alternative is that there is some dependency, okay, that if they plead guilty, that they will tend to get lighter sentence. And then when you reject that null, that tells you essentially that you're supporting the claim of the alternative. And of course, when you now support that claim of the alternative, okay, that there is a dependency, okay, it's not independent, then it will tend to encourage guilty pleas so that they can get lighter sentences. Does that make sense? So I'm going to go with C, okay? Do you understand the explanation? Okay. Question 7. Let me refresh this. The table below summarizes data from a survey of a sample of women. Using a 5% significance level and assuming that the sample sizes of 900 men and 400 women are predetermined, test the claim that the proportions of agree/disagree responses are the same for subjects interviewed by men and the subjects interviewed by women. Does it appear that the gender of the interviewer affected the responses of women? So this is the two-way table right here. The null and alternative hypothesis would be that the response of the subject and the gender of the subject are independent. That's the null. And the alternative would be the response of the subject and the gender of the subject are dependent. Okay, because let's say here, it says here, does it appear that the gender of the interviewer affected the responses? Now, it also says here, test the claim that the proportions of agree or disagree. So, the main thing here is actually this, please. Not looking at it at the interpretation. Okay, that's what you should be looking at. You should be looking at this. Test the claim that the proportions of agree or disagree responses are the same for subjects interviewed by men and the subjects interviewed by women. Please don't read this here. Does it appear that gender affected the responses of women? And then you now go ahead and check B. No. And some people might say this: response of the subject are independent. Response of the subject and the gender of the subject are independent. Response of the subject and the gender of the subject are dependent. Some people might go ahead and say this, but this is the thing here. Test the claim that the proportions of agree or disagree responses are the same for subjects interviewed by men and the subjects interviewed by women. So we're gonna go with they are independent, which means they're the same. They're independent, which means that the proportions are the same. And then the dependent means that the proportions are different. So We're gonna go with C. Okay. So please, this is, some people are confused by this, so don't be confused by it. Okay, because some people will go and say it's B. No, this is what you're gonna be looking at. Test the claim that. Next one, compute the test statistic, the chi-square test statistic. So we have 566, 350, 334, 50. 566, 350, 334, 50. This is 2, 2. 566, 350, 334, 50. And that is 5%, right? 5% significance level. Or you put 0.05 in decimal. 5%, okay. Calculate. So test statistic to 3 decimal places. 80 would be 80.590. Or you can just put 80.59. It doesn't matter. Critical values is a critical value to 3 decimal places. Critical chi-square value at 5% significance level and what degree of freedom is 3.841. 3.841. What is the conclusion? The conclusion is that you should reject the null hypothesis. There is sufficient evidence to warrant rejection of the claim that the 2 variables are independent. Reject the null. Read this first before you select. There is sufficient evidence to warrant rejection of the claim that the proportions of agree or disagree responses are same for subjects interviewed by men and subjects interviewed by women. There is. So, and once you reject the null, it appears there's some bias. Okay, because the null is that there is independent. That the proportions of agree or disagree responses are the same. If you reject the null hypothesis, that means you're supporting the claim of the alternative. We don't say accept. We don't use that word in hypothesis testing. But you have sufficient evidence to now support the claim of the alternative. And the alternative is that, that the proportions of agree or disagree responses are different for subjects interviewed by men and the subjects interviewed by women. So it appears that the gender of the interviewer affected the responses of women. It appears that. Question 8. The accompanying table shows results of challenged referee calls in a major tennis tournament. Use a 0.05 significance level to test the claim that the gender of the tennis player is independent of whether a call is overturned. We want to test the claim that gender of the tennis player is independent of whether a call is overturned. So let's look at the null and alternative hypothesis. So the gender of the tennis player is independent of whether a call is overturned. That is the null hypothesis. And the alternative hypothesis would be the gender of the tennis player is not independent of whether a call is overturned. Determine the test statistic. So reset this. Reset and refresh. Reset and refresh. test statistic to 3 decimal places. Now we click on this icon to view the table. This is a 2 rows 2 by 2, okay, 2 by 2, 2 rows by 2 columns. That's what it means, row by column, row by column. So it's 2 by 2. 290, 737, 470, 616. 290, 737, 470, 616. Two by 2, 290, 737, 470, 216. And we want how many percent significance level? Oh, 470, 616, not 216, my bad. 5% significance level. 5%. Calculate. So the chi-square test statistic to 3 decimal places is 51.846. 51.846. The p-value to 4 decimal places is 0. When you see this thing here, times e to the negative 13, you see this right here, 6.011857678345223 times e to the negative 13. This means 0.000000000. I mean, you count 13 zeros. Like that 13 zeros includes the 0 before the decimal point. That's what it means. So it's 0. It's gonna be 0. Reject the null hypothesis. So there is sufficient evidence to warrant rejection of the claim that the gender of the tennis player is independent of whether a call is overturned. Because you rejected the null hypothesis. Okay? Question 9. In soccer, serious fouls result in a penalty kick with 1 kicker and 1 defending goalkeeper. The accompanied table summarizes results from 296 kicks during games among top teams. In the table, jump direction indicates which way the goalkeeper jumped, where the kick direction is from the perspective of the goalkeeper. Or we have the jump direction and the kick direction. Use a 5% significance level to test the claim that the direction of the kick is independent of the direction of the goalkeeper jump. Do the results support the theory that because the kicks are so fast, goalkeepers have no time to react, so the directions of their jumps are independent of the directions of the kicks? Okay, so here this will be the null will be jump direction is independent of kick direction. Okay, because this is what they say, test the claim that the direction of the kick is independent of the direction of the jump. So, and the alternative would be that jump direction is dependent on kick direction. Let's see the table. Okay, this is a 3 rows by 3 column, 3 by 3 by 3 contingency table. So this is a it's still 2 variables, you know, it's still 2 variables, but it's 3 by 3 rows by 3 columns, 59,539. Let's reset this and refresh. So we come here, we put 3 here, 3, put 3. So we have 59,539, 41,1529, 45,657. Yeah, please leave all this blank. When you put it, just leave all the rest blank. And this is test at 5% significance level. 0.05. Please put decimal. Okay. The test statistic to 3 decimal places is 17.967. The p-value to 4 decimal places is 0.0013. Let's look at the decision, reject the null hypothesis. So when you reject the null hypothesis, there is sufficient evidence to warrant rejection of the null. Okay, there is sufficient evidence to warrant rejection of the claim that the direction of the kick is independent of the direction of the goalkeeper jump. So this results the kick direction is independent. Well, it's not independent of the jump direction, because you're rejecting the null, and when you reject the null, you have sufficient evidence to reject the null, or you can say you have sufficient evidence to support the claim of the alternative, which is that the jump direction is dependent on the kick direction. Right? The way the goalkeeper jumps is dependent on the way the guy kicks the ball, right? So this results, it tends to dash the theory that because the kicks are so fast, goalkeepers have no time to react. It tends to support that theory. So the directions of their jumps are... Okay, wait, it says, do the results support the theory that because the kicks are so fast, goalkeepers have no time to react? So the direction of their jumps are independent of the direction of their kicks. Well, no, you're rejecting the null. The null is that it's independent. So because you rejected the null, is their jump direction of the goalkeeper is not independent of the kick direction of that kicker. So it does not support the theory in this case, because if it supports the theory, that means that you can go with this statement here, but you are rejecting that claim that is independent. Okay, so it does not support the theory. Question 10. A study of seatbelt users and non-users yielded the randomly selected sample data summarized in the accompanying table. Use a 5% significance level to test the claim that the amount of smoking is independent of seatbelt use. A plausible theory is that people who smoke are less concerned about their health and safety and are therefore less inclined to wear seatbelts. Is this theory supported by the sample data? So We want to test the claim that the amount of smoking is independent of seatbelt use. So the null is that the amount of smoking is independent of seatbelt use. The alternative is that the amount of smoking is not independent of seatbelt use. Determine the test statistic. Let's reset and refresh. So click on the icon to view the table. So here we have 2 by 4, 2 by 4, 2 rows, 4 columns. We have 169, 10, 48. So 2 rows, 4 columns. 169, 10, 48. And then second row, we have 153, 18, 36, 15. 153, 18, 36, 15. And we do this with a 5% significance level, 5%. So the test statistic to 3 decimal places is 5.367. 5.367. The p-value to 3, this case now, 3 decimal places. We used to do it to 4, but now it's to 3 decimal places, is 0.147. 0.147. What do we do here? We do not reject the null hypothesis. Please, whenever you put in this, they must have, the 2 methods will always give the same decision. And of course, ultimately, the same conclusion. So we do not reject the null hypothesis, which means there is some independency. There is insufficient evidence to support the claim that the 2 variables are not independent. Okay. Now, but let's look at this first. There is sufficient evidence to reject the claim that the amount of smoking is independent. We don't reject the null. No, we do not reject it. There is not sufficient evidence to reject the claim that the amount of smoking is independent of seatbelt use. There is sufficient evidence to reject the claim that heavy smokers are less likely. Okay, no. So we look at this. There is not sufficient evidence to support the claim of the alternative. Or you can also say there is insufficient evidence to reject the null. Yeah, you can also say that. Because if you look at C and D, no, that is not the null and alternative at all. It's not. So we don't look at C and D. It's going to be A or B. Now, but when you look at A, there is sufficient evidence. A is that there is sufficient evidence to reject the claim that the amount of smoking is independent of seatbelt use. So there is sufficient evidence to reject the null. That is A. But anyway, we do not reject the null. We do not. Do you understand what I'm saying? Now, B, there is not sufficient evidence to reject the claim that the amount of smoking is independent of seatbelt use. Yes, there is insufficient evidence to reject the null hypothesis. Yeah. So the theory is not supported by the sample data. So the correct option is B. Question 11. A poll was conducted to investigate opinions about global warming. The respondents who answered yes, when asked if there is solid evidence that the Earth is getting warmer, were then asked to select a cause of global warming. The results are given in the accompanied data table. Use a 1% significance level to test the claim that the sex of the respondent is independent of the choice for the cause of global warming. Do men and women appear to agree, or is there a substantial difference? This is a 2-row, 3-column, 2 by 3. So I identify the null and alternative hypothesis. So as you can see here, test the claim that the sex of the respondent is independent of the choice for the cause of global warming. So the sex of the respondent and the choice for the cause of global warming are independent. Then the alternative would be that the sex of the respondent and the choice for the cause of global warming are dependent. Compute the test statistic. So here we reset and we refresh. So we have a 2 by 3, 2 rows, 3 columns. Click on this, 2 rows, 3 columns. We have a 301, 162, 46. 301, 162, 46. 303, 149, 49. 303, 149, 49. Now what? Use a 0.01. So that's a 1% significance level. Okay, 1%. Not 5% now, but 1%. Or you put 0.01 in decimal. Calculate. The chi-square test statistic to 3 decimal places is 0.581. The critical value to 3 decimal places is 9.210. 9.210. Or you can just put 9.21. Does not matter. Based on the test, we do not reject the null hypothesis. There is insufficient evidence to support the claim of the alternative. So we fail to reject the null. Now look at this here. There's sufficient evidence to warrant rejection of the claim that the sex of the respondent is independent of the choice for the cause of global warming. So there is insufficient evidence to reject that null. Okay, or you can say there is insufficient evidence to support the claim of the alternative. So there is not sufficient evidence to warrant rejection of the claim that the sex of the respondent is independent of the choice for the cause of global warming. Men and women, because remember we do not reject the null, so whatever they are, whether they are men or women is independent of the the sex of the respondents is independent of what they say is the cause of the global warming. So you would say here this independent. The sex is independent. So because it's independent, the sex is independent of the choice. So men and women appear to agree. When you say is dependent of the choice, then you can say men and women is, they don't they tend to agree, but the sex of the respondent is independent of that choice of the cause of global warming. So which means that the men and women appear to agree. Question 12. A case control, which is also known as a retrospective study. We did this in when we did observation studies and experiments. We did those. Okay, so a case control or retrospective study was conducted to investigate a relationship between the colors of helmets worn by motorcycle drivers and whether they are injured or killed in a crash. Results are given in the accompanying table. Use a 1% significance level. Using a 1% significance level, test the claim that injuries are independent of helmet color. So the null is that injuries and helmet color are independent. The alternative is that the injuries and helmet color are dependent, because it says here test the claim. Compute the test statistic. This is 2 by 5. This is a 2 by 5. Okay, so here we reset and refresh. 2 by 5. So 2 rows, 5 columns. 505, 357, 30, 158, 89. 505, 357, 30, 158, 89. 505, 357, 30, 158, 89. Two 18, 108, 865, 43. 218, 108, 865, 43. 218, 108, 865, 43. Okay. 1% significance level. So this, you can put 0.01, but put it in decimal. Calculate. The test statistic to 3 decimal places is 9.352. The critical value to 3 decimal places is 13.277. Conclusion: do not reject the null hypothesis. There is insufficient evidence to support the claim that the 2 variables are not independent. But like I said, it depends on the way it's worded. First of all, do not reject the null. There is insufficient evidence to warrant rejection of the null. You can say that. There is not sufficient evidence to warrant rejection of the null. Okay, and the null is that the injuries are independent of helmet color. Okay, we are done with the calculations. A dash is a table in which frequencies correspond to 2 variables. Contingency table. Contingency table. Or two-way frequency table. Two-way frequency table. Which of the following is not a requirement of conducting a hypothesis test for independence between the row variable and column variable in a contingency table? Well, in a contingency table, the expected frequency is at least 5. Okay, the sample must be randomly selected. Sample data are represented as frequency counts in the two-way table. That's right. So, but the one that is not a requirement is the observed being at least 5. Observed frequency being at least 5. That's not a requirement. Question 15. Which of the following is not true for conducting a hypothesis test for independence between the row variable and column variable in a contingency table? Small values of the chi-square test statistic reflect significant differences between observed and expected frequencies. I think this is not true. Okay. B, tests of independence with a contingency table are always right-tailed. That's right. Remember, this is always this sample data right-tailed. Test of independence is always right-tailed. Test of independence. Always right. The same thing with goodness of fit test. One-way frequency table is always right-tailed. That's true. C, the number of degrees of freedom is row minus 1 times column minus 1. Yeah, that's right. R is the number of rows, C is the number of columns. That is correct. D, the null hypothesis is that the row and column variables are independent of each other. That's right. So A is not true. Question 16. In a dash, we test the claim that different populations have the same proportions of some characteristics. This should be homogeneity test. Test of homogeneity. Test of homogeneity. Okay, question 17. In a test of homogeneity, which of the following is not true? A, samples are drawn from different populations and we wish to determine whether these populations have the same proportions of the characteristics being considered. Okay, that is true. B, if the chi-square test statistic is large, the p-value will be small. That is true. C, small values of the chi-square test statistic will lead to a decision to reject the null hypothesis. No, it should be small values of the p-value. If the p-value is less than the level of significance, that means it's too small, then reject the null hypothesis. So that should be C. But let's look at the null hypothesis is that the different populations have the same proportions of some characteristics. Yeah, that is true for test of homogeneity. So the correct option here will be C. Okay, and you save this. All right, thank you so much for listening to this video session. If you have any questions, please ask. Okay, it has been my pleasure to teach you this semester. Be good. Have a great night.